Hello. There are a few new pieces of the Rust ecosystem in the language and some crates that I wanted to have a look at. So I thought I would make this little recording to get my feet wet with the whole idea of streaming stuff and make a couple changes to a little web app that I wrote a little while ago using the Universal Impl Trait feature and the new failure crate. So let's go have a bit of a look-see. This is effectively the web app. It's up on GitHub. It's just an example web app where I tried to build something that's a little bit bigger than your sort of Hello World or Introduction to Framework style application. So we're using Rocket, which is a nice little web framework. And the Rocket stuff pretty well all lives in this app folder here, and the rest of the application lives in domain. So it's not really dependent on Rocket in the places that we're going to be touching, which I think is kind of a nice feature. So Universal Impl Trait is where we're going to start. I think it'll be a good little excuse to go and poke around the application and show you a bit about how it works and why this particular feature is going to be helpful. So to have a look, we'll ignore the app for now, the Rocket side. Under domain, this is the application itself, sort of the business logic area. It's split up into a couple of key areas based on some core domain concepts. So we've got customers, orders, and products. That's sort of the things that you would expect. This is an e-commerce store, so there's nothing really surprising in there. And within each of these, we have commands, a model, which is the entity, and queries. Commands and queries are the most interesting thing, the place where we're going to benefit the most from Universal Impl Trait. So if I have a look at one of these, we'll see that there's this pattern here where rather than having a concrete type to represent our command or a query, in this case it's a command to create a product, we have a trait which is automatically implemented for any function mute closure. So that's just a little crate of mine that does a little, it uses the new macros 2.0 kind of stuff. And so we implement this trait for any closure that has these kinds of arguments and returns this kind of result in it. And so then when we're constructing these things, instead of having a type or a struct, we return a closure. So we have this factory method here that takes in all the dependencies that we need in order to construct a create product command. In this case, we need a product store. And then instead of returning a structure, we return a closure. And this really is just a way of making the Rust compiler generate some types for us that save a bit of boilerplate with generics. So if we were going to return a struct that was a create product command that looked a bit like this, it would have to look a little like, you know, let's just call that concrete create product command. It would need to have this T store on it, and then we'd need to have an implementation, a field for that store. And so as we add more dependencies, we then need to add them to the generics here, and we need to add a field for them. Whereas when we're using closures, Rust goes and does that for us. So I'm kind of hoping that this is just going to work with Universal Impl Trait. We will see, I suppose. So I am using conservative Impl Trait, which is where you can return some unspecified type in the return position. So Universal Impl Trait just means that we should be able to turn this into Impl product store and get rid of this and this. So I haven't touched this feature at all yet. So let's just see how it goes. I'm kind of assuming that we can just replace conservative Impl Trait with Universal Impl Trait. So let's have a look and see if that actually builds. This recording is using all of my CPU. All right, we cannot. Oops. So we will need to go and add it as well. Universal Impl Trait, and that hopefully will build. Okay, well, let's try it out and see what happens. So I do have a test using a create product command. So let's see if I can just go impl product store, get rid of this generic, and get rid of this where clause. Let's see if that works. It's a good sign. Hasn't failed yet. All right. Okay. Cool. That's awesome. So let's have a look. So the difference there really is now instead of needing to specify a generic here and then using it as the type of our argument and then using a where clause. I mean, we could put that in there, but I don't like that. We now just need to say impl product store, and that's it. So that's pretty simple for this command. Let's go and find a more complex one. I think customers. No, maybe under queries. There we go. Well, this one needs 2 generics, and you can see where it starts to balloon, especially when I have these ridiculously long trait names. But now I should just be able to say impl customer store. And this should be, I'm just going to copy that. Impl get order summaries for customer query. Cool. Get rid of this. And that should be that. So this is a bit of a more complex example of this pattern. So now we return a type that you don't know, you can't actually name it. All you know is that it's a get customer with orders query that has a couple of dependencies. And the thing that I really like about this approach so far is that it gives us a way to separate our operational state from our application state. So in order for this particular implementation of the query to work, we need a customer store and we need another query. But as far as the trait knows, all you really need is to input a get customer with orders type, and you'll get a result out at the end, which is a customer with orders, which is this thing. So it lets us sort of keep that separation nicely, and it makes it easier to extend the application in the app layer itself. So we have this obvious place where components get plugged in, where we can extend things. You might see this little resolver type here. This is just a concrete class. It sort of lives here. It's basically a service locator. If you've ever come across that pattern as sort of an old poor man's approach that was superseded by IOC in the old .NET ecosystem. I think this approach leverages the Rust language a bit better to avoid some of the pitfalls that the old service locator had in .NET, and that is that we're not conflating this concern of having this globally shared object in the middle of our application state come and decide things. That makes testing hard. So because this is an impl block, it's not actually tied to the inside of this query. So we're not depending on some global state within the application block itself in order to resolve dependencies and work with them, which makes testing a nightmare. So it's all independent. So I think we do effectively get away from that problem. And it's sort of it's a nice, easy to implement middle ground between having a full-on IOC container and not trying to do anything and ending up with soup. So I think it works out quite well. So I'm just going to quickly go through and update all of these commands and queries to use the Universal Impl Trait. And when we get around to it, we'll have a look at the model as well, which I think we'll need potentially to have a look at and update for this. So that now becomes impl customer store. Cool. All right. Let's have a look at the model. So this is our customer model. Each of our core domain parts has a model with it, and that defines the entity itself, which is a customer, and it defines some data as well. So the split here I made really because Rust has some nice features for dealing with structures, so for destructuring them and being able to have disjoint borrows on fields and things. So you kind of lose all of that when you use getters and setters. So what I wanted to do was keep those nice ergonomics of dealing with structures, but also encapsulate our invariant so that we don't end up having customer data, for instance, end up in a state that's not valid, even though there's not really anything on the customer. If we have a look at product, for instance, we might have an invariant on the product data, that the price needs to be greater than 5 when the title is more than 10 characters or something. These kind of cross-field invariants are things that you can't enforce when your fields are publicly settable, because you can just go and set them independently, and you can go and hydrate or hallucinate some product data out of nowhere, even though that might not be valid. So what we actually do in this case is we have this semi-private method from data. So you can create a customer entity from data within the model module. Otherwise, all you can do is sort of get these read-only views of that data, and you can, or you can convert it directly into data, and then it's no longer a customer, it's just some record type. So you don't lose the ergonomics of dealing with structures, but you can also enforce invariants across this type. Something that's a bit potentially odd with this that I think might cause problems down the track in a larger application is that we are effectively tying customer to this customer data representation. So here, where we return a borrowed customer data from borrow of self, there's not really anything that we can do except return the customer data that is within customer, unless we can somehow in a sound way get a borrow of some data, of a customer data for that lifetime. A way that we can avoid that is, instead of returning customer data that's borrowed, we have some type where we move that lifetime onto the fields of that type. So that would be, a customer data of dash A, where the ID is a cow, moo, or dash A and customer ID. So we have that per field lifetime instead of having it over the entire struct where we need to already have a customer data to return. But that's not really what we're working on today anyway. So let's have a look at the store and see if there's any generics in here that could benefit from Universal Impl Trait. Not really. So the stores are self-contained and they live within the model as well. So they can make use of this from data method. So it means that any data that we get into the store, we can get back out. I would like to replace this with Diesel one day, so we can store our data in like Postgres or something. But for now, we just have these little in-memory stores that are just, a locked hash map. They could be a lot better, but it's good enough for testing. Okay, so there's nothing really in there. We've done this one. Get customer. Let's have a look at that. So that needs a store as well. So pretty well all of the commands and queries end up needing a store so that they can work on. And if I remember rightly, let's have a look. Yeah. So the model stores are also only accessible within the domain module of that type. So only a type within the customers module can get a customer store. So a product can't get a customer store. It would need to work through commands and queries. Commands and queries are sort of the public API that we expose for each of these core domain concepts along with its entities. So using Rust's modules, I find has made it possible to get some really nice sort of sub modules or layouts within the application that are easy to enforce. So we can easily reason about who can access what, and that makes it possible to extend a work with the application without having to sort of have cascading changes throughout the entire thing, even though we are doing cascading changes right now, but that doesn't count. This customer's done. Let's have a look at orders. So we can add or update a product. Yeah, this one needs a couple of types, and so this is getting really quite difficult to parse. So I think this is going to be great once we get this working on Universal Impl Trait. That's an ID provider, and that's a get product query. And that's getting kind of hard to read, so let's just push all of those down onto this line, and that can just go like that. That'll do. Rust format will probably come along and change that into something weird. I don't need these. There we go. That's a lot better. So now we know that we need an order store, an ID provider of line item data, and a get product query. And that's what this command uses. Nice. All right, let's have a look at this one now. Impl order store. Impl get customer query. Oops. I was thinking about doing something a bit like this within some other projects I work on. I'm finding as they get complex and as you need things like loggers that are scoped to some particular computation or particular process, that having easily being able to produce a type that represents that process rather than sort of thinking in terms of objects that contain state and behavior lends itself quite naturally to extending in that way, especially since we don't really have like nice logger enrichment using globally accessible loggers. It's like when you're using things like futures or something, you can't really thread local store things because that future might be executed across multiple threads. So being able to have your types encapsulate all the state that they need independent of wherever they're going to run would probably make that a lot easier. So I'll look into that one day, but not right now. The model for orders. This is probably the most complex model in the application so far. So we have a couple of things in here. We have orders and line items. So an order has multiple line items, and we have some invariants around the set of line items within an order. So you can only have a product in an order once. So you can't have two line items for the same product, just because it would be kind of weird when you try to change the quantity of things. So this is kind of where you can see having the order entity being the sentinel of that state becomes quite nice. So we go and destructure the order, do some stuff. So if I have a look at, say, add or update product, for instance. Yeah, so this is a case where we're destructuring the data from an entity and just grabbing its ID and doing stuff with it. So if we had getters and setters, then this would be a bit trickier to do. And I suspect that as you get stuff ending up being a bit more nested still, being able to just reach as far into the structure as you need and grab the bits that you need for the lifetime that you need them is going to be quite nice to work with. Got my iced coffee. Yep, so that one's done. Let's have a look at queries. Get order summaries for customer query. It's just an order store filter. Yeah, this trait is a bit, the order store filter trait's a little bit unfortunate actually. So because we are just storing our data in hash maps in memory, I didn't really want to have just these random methods on the store trait for things like, get an order for get all orders for a customer, for instance. I'd rather just have the stores be effectively like, like a Redux kind of store where you just you go and update bits and then you get bits, and that's pretty much it, and then everything else operates on that. But at the same time, when our data is in SQL, we want to be able to execute queries and filters and things on them. So so as a bit of a stopgap, I've ended up with this AutoStore filter trait that you just pass in a function predicate to, and it'll return all the orders that match that predicate, which is going to entirely not work with Diesel because it has its own kind of predicate types that you work with. So it's going to have to change, but it's only re-exported in orders anyway. So once we do move orders to use a SQL database and we need to tweak this trait around a little bit, it's only orders that are going to be affected because everybody else can only see commands and queries. And I mean, we could inline SQL in these queries and nobody would ever know. It would be our little secret. So that would be fine. But for now, that's what we've got. Cool. So let's have a look at this. Get order with products. Orders have the most interesting commands and queries. They've sort of ended up being a central type in our domain, where you have customers have orders, and orders contain line items, and line items have products. It sort of all ends up being tying back to orders in some way. So they have the most complex commands and queries so far, and even then, it's not unreasonable. This is a bit dense, but it could be spaced out a bit better and still be quite readable. Order store. Cool. Done that one. Set product title. It's just a random little updating one. I don't think you'd really, I mean, it depends on what you want, but having a separate command for each field that you want to update could sort of be nice if you're going to queue, like if you're going to queue updates to some entity on your client and then send those through individually. But I don't know, usually just updating the entire entity in one hit ends up being easier to manage. So this will probably go away, but for now that's what it is. The product store. This auto impl syntax is a little bit weird, where we have auto impl with just an ampersand. That's just a little compiler plugin that will go and automatically implement this trait. So in this case, it'll implement product store filter for any ampersand dash whatever T, where T is a product store. So Rust treats ampersand T is different to T, which is nice in most cases, but in some cases you want to be able to pass owned or borrowed data in a case where you could use owned or borrowed data and nobody would be able to tell the difference. And that's kind of where auto impl makes it convenient to do that. So without having auto impl for ampersand and arc, we'd need to do those manually, or we'd need to know concretely, say when we pass in an impl order store filter or something, we'd need to know how that type that the order store filter is implemented for is being stored. So we need to know, whether we're going to be storing those in boxes or RCs or ARCs or whatever, where I don't really want to have to worry about that. I'd rather abstract the way that dependencies are stored from where they're being used. So all we know is that's it. That's what we got. So where are we? Product store. Product queries. Product store filter. So this is another of those little filter traits that I'd like to see the back of. So we just pass in it has a filter method on it. It just returns an iterator. So at least it's a result of an iterator, I guess. So it could come from anywhere. Get product query. Alrighty. So that looks like all of the commands and queries that we've gone through. So let's have a look at how they get used. That should actually remain the same. So this is our rocket route for customers. So if you get /customer/ID, then from our service locator resolvery thing, we will grab a get customer with orders query off that. We don't know anything about that except that it implements that trait. We then get the customer with the orders with our input, and then we return that as JSON. So that's really all the rocket side does. And I can't imagine us needing to do a whole lot more than that besides things like authentication and I guess collecting errors and things like that, which is something that I would actually like to look at right now. All of our errors come back in 200s, which is just not right. So that looks pretty good. Let's see if it actually still builds. And if it does, then I'll try and run it and show you how it all works. It does not. Yeah, right, I forgot to remove some generics. Set product title. Any others? Get order with products query. There we go. And let's have a look. Oh, whoops. That should be impl. Let's try that. Okay, I missed another one. Get product query. Oops. Get product. There we go. Yeah. Okay, let's try that now. Yeah, still a few I've missed. Get product summaries. One at a time. I must have missed 50% of these or something. There we go. Okay, let's have a look at the diff. I'm just curious to see how much we've gotten rid of in some cases. It's not bad. It's getting a bit long. I should probably run a cargo format and see what it does. Pretty sure I've been formatting this Oh, there we go. I do even have it installed, which is nice. Well, it looks pretty much the same. Okay. Well, I'm really happy with that. I think this approach just would not work without Impl Trait. Well, I mean, it wouldn't at all, because we wouldn't be able to return closures from these functions because we don't know. We can't name the type of them. But I think this is really nice. I think there's still a few things I'd like to work out with this pattern. I think, say if I was going to add like a logger in here, anywhere in our tests and whatnot that we're calling this method in order to get our implementation of the get order with products query, we would then now need to start passing this logger in. So adding arguments or adding dependencies in here is going to break anywhere that we're calling them. So I'd like to figure that out at some point. Maybe we need some way to make this resolver better to work with, where we can use it, I guess, a bit more like an IOC container and specify what we want dependencies to look like, so that we can fill in the blanks in these functions with various types as we want. So in tests, unit tests, for instance, we probably don't care about logging it all, but we want the freedom to add that stuff in without having to break all of our tests. So I haven't really given that a lot of thought, but that's something that I think is going to be a bit less than nice to work with this. But now we've got a building, let's give it a run and see how it works. So it's a really simple, mostly CRUD application. All we can do at the moment is create customers. I probably should have said this at the start, but all we can do is create customers, create products, create orders, and add line items to those orders for particular products. The API is very simple. And I probably find that if I actually tried to put a client in front of it and start using it, then I'll probably end up wanting to change it all. I should add some integration tests to it using request or something at some point. I think I'll need to do that in order to verify that errors come back with the status code that we expect anyway. So I'll get through this pretty quick because I want to have a look at the failure crate. So I've only had some pretty quick looks at it. I haven't really started leaning on it for anything. So I'm interested to see how we can utilize it. I was originally going to use error chain, but failure seems to be what's popular these days. And it fixes a lot of niggling errors or issues that you get when trying to deal with errors in Rust. So I'm looking forward to seeing how that turns out. So this is running, so I can fire up Postman. Good old Postman. I still love you, Postman. Useless Postman won't start. There we go. Stop hating on Postman. All right, there we go. So if I go, that was what we're running on. That's probably going to give me a 404 of some kind. I should probably make this API self-describing. That shouldn't be HTML. It's a bit not what we want. Self-describing, so that if you sort of pretty well any route that you hit is going to give you something. And so if you just hit slash, then we should give you links to these other routes. So some resource describing, hypermedia API stuff, That's always very nice to work with. But thus far I've been really lazy. So the route should be /products. I wonder if that does anything yet. Have I done something with that? Nope. So we'll need to go and put one. I'll put a product. And I believe we aren't specifying IDs on the client at the moment, because the IDs are UUIDs anyway. I mean, we could specify them on the client. There's no reason really that we can't, but I'm not. So the data is type and price. So I just put, it's a put, yeah, it's a put. And I might need to specify a content type, application JSON, and I'll put a body on that. Oops. So the title will be my product, and the price, which should be a better type than F32, could be $5.99. That's a good price for my product. Cool, and that's our ID. So if I go and dump that on a new request, okay, that's probably why. There we go. So there's our product. So that's now sitting in our store, in our sophisticated locked hash map. So now that I have a product, I can go and create a customer. This is really tedious, so I need some seed data and some proper integration tests that can go and do all of this. So with customers, we put, okay, that's it. Cannot type. So that's just a put. Then we should get a customer. Okay. Put / customers. Do I need a slash? That would be weird. No, okay. I wonder what's up with that. It's probably something really obvious that I'm just not seeing for some reason, unless I just haven't hooked it up for whatever reason, but I was. There's a put. Do I need to specify a content type? Don't know. Okay, I did need to specify a content type. There you go. So now I have a customer. So if I go and get that customer, did that again. There's a customer. We have no orders right now. I'm going to move this tab over here so I can come back to that later. There's our product. Don't need that one. Don't save. And that's our customer. So I don't need that one. I can grab it from the other tab. So now let's create an order for this customer. So on the orders side, we put an order. Oh, I see. And then we need to post a product to it. This is pretty tedious to work with. But I mean, that's all right for now. /orders. Put /orders and the data as a customer. And that should be put. And the body is this customer ID. Oops. there's our order. So now we'll go and put a product in it. Host orders /ID /products. And so what is that? That's a post. So back on our product, that's this. And the header content type. Is there anything else I need to put in there? Product quantity, right. So quantity can be 2. There we are. So that is now our line item ID. So if we go back and grab our customer again, we now have some orders in there. So I think I should be able to get this order with its line items as well. It's kind of a bit icky that in our API where our resource is a product on an order, where it's actually a line item that we're returning. It's not great, but that's okay for now. / that's the order ID. Not found. Was that the order ID? No, it was not. That was something else. Right, okay, so there's our order with our line items. So that should be products, or we should be putting a line item here. So we have the line item ID, the product ID, the title, the price, and the quantity. So that's pretty well all that this application does right now. You can just put and get stuff. But even in there, there's enough that we can, I guess, extend this into more interesting and more complex things. So our domain could contain some background processes that we need to run for, I don't know, updating stock quantities or things. My iced coffee's gone warm. Okay, let's have a look at failure now. So here it is, the docs for the failure crate. Cool. Okay, I wonder if there's more on the GitHub page. I just want to have a look at what the syntax for the derive is. There we go, that's what I wanted. So we derive fail. I wonder if that needs to be an enum. Only one way to find out. So let's just add it in. Let's just go star. Cart go. Run a cargo update. Probably didn't even need to do that. I'm going to end up with stuff that doesn't build now, maybe, but we'll see. Okay, so while that fetches, nice Australian internet, I'll just go and start plugging it in. So I'm assuming there's going to be some failure derive crate. I'm going to assume it's called failure derive. We will see. Let's just go and kill that. So now we can go and download failure derive. Hopefully that is actually the crate name. Otherwise I'm going to end up hunting around for it. It's sort of the convention for crates that have a custom derive in them is to put the underscore derive on it. One of one of many conventions set by Serde. Maybe set by Serde. At least it's the first kind of crate that I saw really heavily leaning on derives. It's one of the key drivers for stabilizing that in the first place. Well, that's compiling. It's probably because I did a build instead of a check. Let's just go with the old cargo check. All of my cycles are being burned on recording. So cargo is finding itself a little bit starved, taking ages. While that happens, have a bit of a look at what we're doing. So I've used failure on a little crate recently, but I only used its error type. So failure gives you a generic error type that you can just pass around and do pretty well anything with. You can just throw string messages into that or encapsulate another error and then throw some context on top of that. So you don't need to derive custom types if you don't actually have a reason to. So you can just throw context on things. So if all you need to do is capture errors and those are just going to end up being logged somewhere along with a backtrace and some additional context, then you really only need to use this. For this application, I'm thinking that there will be some cases where we do want to inspect the error that we receive and then return an appropriate status code depending on the error. So if we get an error from the store that says that the data couldn't be found, then we return a 404. Although in that case, we might actually just return an option if that's a sort of a common part of our happy path where there's going to be data that's not available or not existent for whatever reason. But for now, for the case of the errors, let's assume that we're going to communicate any non-standard success or any non-standard or non-success scenario through an error variant, and that's going to be something described by failure. Oh, what's this? Is this docs? It is loading. This is why I'm not streaming. I don't think our poor copper could take it. All right, so it's a little book. Cool. Let's have a bit of a look through this. Fail is the new trait. Right. Okay, so that's sort of a way of iterating over that. I wonder if there's an iterator. So I know error chain has an iterator over causes. Context. Deriving fail is kind of what I'm interested in for now. I'm sort of already familiar with the error type. Got a pile of new dependencies to compile. I can't believe how much resources OBS seems to require. Like, this is really churning. It's grinding. Laptop's probably going to melt through the table. I guess the thing that I don't really want to be doing is, in cases where we are expecting to return information that we want our domain to deal with, I don't really want to do that in an error type that then needs to be downcast and then inspected. If I'm happy to do that sort of at the rocket layer to figure out what kind of a status code we should return. But within our commands and queries, so if we call the store and we get something, then I don't really want to have to go and do downcasting. We could just use concrete error types in that case, I guess. That would be fine. Or maybe this is a non-issue and I'm already returning option. I am already returning options. There you go. So we should never get a result to say that some information or some data wasn't found. So now I'm assuming that if it wasn't found, then the query is probably going to return an error. Yeah. Okay. And we're tying the result here. So since we are using a specific result type on the trait, we need to keep the error there generic. Maybe we should be returning options out of queries as well in the case where the data is not found. Because we consume queries from other queries elsewhere in the application. But if all we can really do is just toss that error back up for now, unless we have a create or update. I'll punt on that. I'll deal with it another day. All right. Now let's see if we get this any quicker. Should be. So we've got failure in here somewhere. There it is. Failure derive. There's failure. Cool. So I guess the first thing that we can do is instead of using, I kind of got this ready for error chain by specifying type aliases for the errors where all the errors just happen to be strings. So I guess the first thing that we can do is replace these type aliases with failures error type and just use those. Or maybe I'll just go and re-export a generic error type just at the root of our domain and then start using that. Yeah, I'll just do that. So let's say this can be the main error type. So that will be type error equals failure. Now I'll probably just have to use failure. But I will let that compile and fail first. I suppose it could go in its own module, but that seems a bit extreme. Especially since it's just a type alias. Yeah, so I'll just need to use failure. And then that will just be domain error. And anything that we get out of the domain is going to use this error. And the carrier trait will work just fine because it's all convertible. So that's now domain error. So now we go back through all of the modules and replace these error types with the domain error. So I imagine I'm going to be using that a lot, so I'm just going to do that. And I'll probably do some checks as I go on this one rather than with the conversion to Universal Impl Trait, because I might end up breaking stuff. Should probably run tests at some point too. No error in domain. That's because I put it in the order or the customers module, so that goes in here. Okay, I will just go and create another module for error, just so that it's still consistent and easy to find things. So that will be Yeah, I'll just make it more. This is the most useless module ever. But at least at looking at the file system, you can tell that there's an error somewhere. So, you know, whatevs. That's fine. That should be public. So this now becomes... oh no, that will still be the same. All right, fine. Use main error and resolver. All right, so let's see if that builds now. I mean, it won't because we're still implicitly treating, see, errors here. Oh, maybe that'll convert into it. Yeah, it does. Okay. No, it doesn't. Error is not implemented for string. Right. So we'll need to use the old failure error message. And so now where we're returning these would need to be like this. And all of these. So this won't actually work until I get the others working. So I think I am just going to have to sweep through and update them all and then see what breaks. So that'll be error MSG, error message, error resolver. All right, so I'll just go through each one. So let's have a look. These are using results. Domain resolver error MSG. So this one doesn't need error message. The store. Okay, so we're not using the domain level resolver here. And that's so that we can keep those the stores private. So there's a sub resolver for those. These need to return error messages. It's probably a better way to chain these actually. Actually, let's have a look and see whether there's a... I saw there was a bail macro. Yeah, okay. Ensure format error. Format error. Right, okay. That's nifty. I mean, these are sketchy errors anyway. These ones. So there's a couple of things in the store that we do that can return errors. I mean, well, actually, this error can occur if you have concurrent updates to an entity. But yeah, this whole try and read or throw an error is not really great, because if this throws an error once, it's going to throw an error consistently. It's never going to work. And so we're just going to end up always throwing errors, but that's fine. We're not actually intending to ever use that store for anything important. Okay. Oops. So that would be error message, error, and resolver. Should have a not found error. Like, really, that should include the ID or some information on it. let's just get this working and then come back to that. Okay, get rid of that. Like really having a not found method in the error would be good. I am now feeling like since there's stuff in there, we should just make that a pub mod. And just go ahead and break all the stuff that we've already done. But that's okay. At least it'll be an easier to copy little using snippet. Use domain error, error message, and error. The rest of that should look the same. Okay. Get rid of that. That becomes that. Yeah, so I think it would be good to have a not found method in there that we can use. Well, IDs are not convertible, so we'd need to, if we were going to pass an ID, we'd need to do something with that. But that's all right, we'll figure that out. Okay, update that. All right, orders. Oh, I wonder if there were a bunch of error variants I didn't delete. No, looks like I got them. So that is now, oops, domain error. So we don't need the error message. Oh, there it is. So we definitely don't want to be returning the values of these errors back to the client ever. But there'll be a point where we split it, where the error itself will get logged along with its backtrace and context, and the client will just get something generic. Okay. I wonder if I've gone, oh, the test should all still work, but I'd be curious to know whether there's going to be any little bugs in the Universal Impl Trait. So far, I'm really impressed with it. I think that the way that I'm using it's a bit kind of wacky, and it still works really nicely. Okay, any more in here? Yep. It probably is worth making the entities have concrete error types that implement fail. I've already got that. All right. Yeah. Little version check. It's very simple. It only works because we can get an exclusive lock on the entire store, which is why you'd never want to use this thing in any production workload. What's this one? Setting a line item. probably go and replace all of these blocks in one hit, but I don't mind occasionally just going and trawling through the entire code base. Well, not the entire code base, but most of it when it's this size, to just see if there's anything else that looks a bit nasty that I should Boy Scout while I'm around. Apart from the fact that it even exists, it seems alright. The order's memory store is it's starting to get a little bit tabular. The dependency that line items have on orders is something that I'm a bit hesitant to increase any further than I already have. Otherwise, we may as well go and make them really tied together. Oh, there we go. I forgot to remove that. Just as well, coming back around and looking at things. I mean, Rust would tell me, but save my poor CPU some cycles. So we don't need the error message variant here. Oops. There we go. Do need it here. Oops. And there is an error type here. Get rid of that. The rest of that should work out. All right, error message. I'm not really sure how you, I don't know, I guess for lack of a better word, intercept errors or responses in Rocket yet. So that's going to be a bit of an experience once I get to it. It's probably very simple. Rocket has a very nice development experience. Pretty well everything that you want to do is supported in a first class way in some form. There we go. Getting there. It's not too many left to go. There we go. Now the product store. Yep. Cool. Okay. Now I've just got a couple queries and then fix the pile of bugs that I've probably introduced. Don't need the error message variant here. Oops. This is probably not very interesting stuff to watch. Okay, I think that's pretty well it. Let's have a look and see how many errors we get. Probably need to update the app as well. I think they do actually return concrete errors. We'll see. It'll probably fall over. Yep, big pile of errors. So yeah, so that's in app. Right, so up to the app layer, we now need to go and update things. So that suggests the domain error probably isn't the type that we should be using in the app. We should have an app error. I'll just go and create one here. Oops. So just so that they're not explicitly tied together, and if they ever diverge, we can add a from impl and we can still use the carrier. So I'll just use failure error. I'll use failure. That's all I need. So that will just be app error. And I can get rid of these. Okay. I already have a, okay. I'll go and add. Actually, yeah. Okay, I'll add a module for it. I was kind of hoping that the modules under app would all be strictly related to routes, but I guess if that becomes tricky, then we can go and move either all the routes, probably move all the routes under another subfolder. So we use failure. Oops. So that'll be the main application error. All right. So we don't need to use failure here anymore. And that will now become use app error. So there shouldn't be any case where we're composing errors on the routes themselves. So I don't think we'll ever need to use error message. So let's just get rid of that. And this one. See if that's enough to make it work. Or at least almost work. Okay, what have we got? Right, I suppose I should actually declare the module. Try that again. All right, so there's a couple of other bits that I need to convert. So besides these core domain modules, we also have these other helper types. So ID, for instance, contains an ID that is parameterized by some type and is not equatable or convertible between different types. So you can't compare a product ID to an order ID, even if they happen to contain the same value. So let's just go, probably will need error message in here. Right. So we should just be able to put that in a compat. So this here is a standard error where I have a very poor man's method of wrapping it. What we should be doing is putting that in a compat. So there's backwards compatibility. We're using error type. Oh, I should probably read those sections at some point. Where's the old backwards compatibility? Thought I saw that somewhere. There it is. Right. Okay. So it may already be compatible with failure. So I'll try that first. Oh, there is an iterator over the clauses there. So I need to look at error, see if there's some other way of tossing a clause into it. I see, so compat is for the other way. If you want to say take a fail and put it into an IO error or something. Okay, so I should just be able to do a from conversion. So that should be like that. Might need to be into. Usually I use into. So that we say that we're taking this error and converting it into. I mean, it would need to be, either would work actually, it would look the same. But that just sort of reads a bit better, I think. So do we need error message? Doesn't look like we do. Let's try that. We use ID providers a lot. The idea with that is it's an abstraction over whether you're going to, say, calculate an ID out of a table, or you have an ID up front, or you're going to just create one yourself. So there's a provider for each entity. So there's a product ID provider and a line item ID provider. Count ver. Okay, let's try error from. I suppose because we're using the carrier, so there's multiple levels of indirection in there. So maybe I can just use carrier there. Let's try that. Expected string found error. Line 9. Right, yes, there's a rocket specific ID. Nope, that is the same ID. It's just using that particular error. Okay, I'm going to use the actually I'll use the domain error. I think it's reasonable in this case. So let's use domain, because I mean this really only lives up here under app, because I don't want to move any rocket concerns into the domain folder. So let's see how that goes. Please wait, building takes a while. Cool. All right, we've got this thing building. So now if I do a cargo run, we should be up again. I won't go through that whole rigmarole of creating customers, then products, and then orders, and then adding line items to them from before. But at least we'll kind of see what happens if I try and say execute this request now with our new run, because our data is just stored in memory. Running it now means that we're going to have a fresh new set of stores. So that should return a not found. Or maybe it will return something really weird. We'll find out. Because they were just strings, and so those were easily serializable, but we should have some particular message, so then it's not possible to leak things like backtraces and things in API responses. So they should boot up in just a sec. Or ignite, I guess, is the rocket terminology. All right. We get this fantastic HTML formatted 500. What if I said accept. Cool. Still gives me HTML. Oh well. I'll deal with that another time. So just to go back over what we've done. So we've moved all the generics to using Universal Impl Trait, which is strictly nicer than what we had before. And now error types are using the failure crate instead of strings, which is also strictly nicer because now we have the same. It's just as easy to use the errors, but now we get nice things like backtraces by default. So the next time I run through things, I will try and make Rocket return something nicer than that little formatted error page when you receive errors. But I think this is enough for now. So am I on the master branch? Yeah, I am. So I'll just go and add those. Actually, I'll check out a new branch and do this as a PR. I'll do it properly. Oops. So that can be, actually it's more of a chore really. So that's Impl Trait failure, errors, two things in one commit. Oh well, she'll be right. Check that in and call it a day. So that is Universal Impl Trait and failure crate. I could do them separately, but maybe I'll set up stream. This is probably actually not going to work with my internet. Oh no, look, it did. First time. Most of the time when I try and do a git push, something on my network falls over. So I'll just open this up as a PR. I didn't actually run any tests. Might do that quickly. So we're going to use the new Universal Impl Trait feature. And there were two issues. Oh no, there was no issue around Universal Impl Trait in here, but that was number one. There's still more to do on proper error handling, so I'm not going to close that issue with this PR. But it's sort of good to get that started. Great. And with that, I think I'm going to call it a day. Thank you all very much. Catch you next time.